Doing stuff with Danger.
G'day. Today we're going to change the alternator on this because it's not charging. And the battery was going flat over a couple of days, just moving it around and things like that. In the past 12 months, we were helping a company develop their 240 amp alternator. And in exchange for helping with that, we've got a trial alternator. So I'm going to put the 240 amp alternator in this, which is going to require a new battery positive cable to be made. I'm also going to probably remove a few more items while fitting it so you guys can actually see, otherwise it's sort of a bit pointless filming this. So I'll show you the difference between some of the alternators and we'll get into it. Alright, so here we have 3 alternators. The middle one is a genuine Toyota 110 amp alternator. The one to the left is a 150 amp Baxter's alternator. And this bad boy is the 240 amp with a giant heatsink on the back to stop heat. There's the standard Toyota post versus the slightly larger 150 amp post, and then you move across to the much larger 240 amp post. Note the difference with the heatsink at the back there, absolutely huge. Alright, we're going to try POV again because I had a lot of good feedback from the last one I did. So I'm just going to take the wing nut off the airbox. Containers are your friend in this instance as well. Sorry, the POV thing's it's a bit tricky to operate, and I was noticing I couldn't see. So I'll pop you up there. Alright, get rid of the rock cover breather. I'll replace that later. There's a 10mm hose clamp. Some of these vacuum hoses can come off. Clip. Clip. Another one. Now if it's cold, just watch your fingers because they hurt. Sometimes I find a bit of a twist can get that off, but I think everything on this has just not been off for a long time. Oh, there we go. There you go, this air filter, 400,000, 4th month 16. And it's got 450, so this air filter's done 50,000 Ks, so the whole car's done 50,000 Ks in 9 years. Alright, now there's a 12mm here, and a 12mm here. Alright, now I should add, at this point, disconnect the battery or negative terminal at least. I'm going to attempt to unplug the back of the alternator first. Some of these plugs can get a bit contaminated over time, and they fill up with dirt and mud and they get stuck. We've got the 10mm alternator wire. Oh, geez Louise. Not as tight as that should have been. So what we're going to do is this wire here, we're actually going to replace that with a heavier wire and run that directly to the alternator. There we go. You can see there's a little Christmas tree sort of thing. Is push in there, and out she comes. Now that leaves us with the 12mm adjuster here. There's a 12mm just in front of it, and there's a 14mm at the bottom. So we'll start by getting to, that's your 12mm adjuster lock. And then just here, I don't know if you can see. Okay, so our adjuster is loose, our adjuster pivot lock is loose, and the pivot 14mm at the bottom is loose. The alternator is now movable, but it's still, I think it bottoms out and the belt doesn't want to come off. So what we can do is we can take undo the pivot, the adjuster, slide all the way, and sometimes it'll allow you a bit more adjustment to push the alternator in to get the belts off. Now it seems a lot of this hasn't been touched in a long time. There's your pivot bolt. Clean the threads up. There's a lot of stuff falling out of this. There she is. Looking a bit worse for wear. Alright, so part of the new alternator is going to require a new battery cable to be made to run from that side across the top and then over to here. I was going to make that first and deal with this another time, but I can't not deal with this anymore. It's so bad. This wire here is for the intake heater, which the relay's just floating around there doing nothing. So I'm going to pull the battery out and I'm going to take everything here that doesn't need to be here out. So I've got a clean slate to work with. I was going to do that the first time, but I thought I should be able to get away with this, but I can't. I can't let it go any longer.
Here you'll see we have nearly 9 kilos of unused wiring. There is a head unit in there, but with the weight of the box, there's still at least 9 kilos of junk.
Alright, that's enough for this today. It's made a dent, and I'm pretty sure I've just got to take that off, remove this. And there's some stuff on the other side which goes into the cabin, but other than that, this is all the back to factory now. So I need to treat this rust later, but I might just put something on it now for the time being because I need to get this out back off the hoist for the end of the weekend. Battery tray back in, make the cable for the alternator, and I did notice that the fuse link was blown for the heater relay as well. But the main thing is just to get it running so I can get it back off and we can work on the rest later. Alright, that made a dent, didn't it? big pile of wire behind me. I don't know what half of it was for. Pretty much everything is out of the engine bay. Just got to take that out, take the hot water unit out. There's twin core here, which has got to get pulled out from underneath. There's some wires on the other side which are going to pull back into the cab. The cab's got so many more wires, I've got to deal with that later. But my main thing is just to get this running again. I need to treat the rust here. I just want to get the battery tray back in, hook the battery back up, make the cable for the alternator, get it running so I can get it out, because I need this space for work. Alright, I'm just going to put some WD here, just to cover the rust, I guess. I'll deal with it later on. I will put a dual battery tray back in it, a proper one, the big double unit, but I don't have one. I didn't actually expect to go this far, to be honest. I was only supposed to be fitting an alternator. Another thing these are really sensitive on is this spill control module. If they're not earthed properly, you'll have all sorts of cutting out issues.
Now you'll just see we're getting the measuring tape out to measure up the new battery cable. It's a pretty old, poor form way of doing it, but it works. On the bench with the wiring, we're just going to measure again, cut the wiring, use the wire strippers to strip the end off, get a bit of heat shrink, some clamps. Now if you don't have a crimper, you can use a vise with a bolt, and that will crimp it enough to do the job. And when I got this alternator, it came with some paperwork that showed me the amps at RPM specs, and the pulley on this one is actually quite smaller than an OEM pulley, which I don't like. So what I'm doing is removing a pulley off a good alternator and swapping it, and after some careful measuring with an old belt I cut in half, you can measure the circumference of the pulley, and then you can measure the circumference of your crank pulley, and that'll determine your alternator RPM at engine RPM. And as you'll see shortly, there will be a diagram that had the alternator RPM versus amps. I was concerned that the amps were going to be too low at idle and it wasn't going to charge, but after we did this, it showed that it did work. I was just thinking maybe I shouldn't have told you to let you wait for it, but it definitely worked, and I was happy enough with that, because if I actually did the pulley that was on it, technically the alternator would over rev at 4,000 engine RPM, which is no good. Not that we're ever going to rev to 4,000 RPM. And there is said sheet. New pulley, new old pulley, throw her on, get her back in the car. Little did I know, I was about to walk into a problem. Not a big problem, but still a problem. When I put the new alternator in, it didn't fit. Even though most of our trial and error with our 3D printed alternator they supplied originally, we shaved it like this, but for whatever reason it came back standard again. So we had to remove some material off the alternator case itself, and then once we got the alternator back in, we realized that we also needed to remove some material off the bracket, and then we had to elongate the holes in the bracket because it still wasn't big enough. So I think this alternator is going to have to come off and go back to the manufacturer so they can modify it some more on that front case, because it's not going to work. Not a huge issue. We got it to work and fit in the end, but it wasn't the ideal outcome I was hoping for on the day. I was just hoping I could just put it in and run a new cable, and off she went. Sees me mucking around, trying to size everything up, making sure everything was good, nothing was going to rub, touch, fiddle around. Notice the years of dirt and dust that sit behind the water pump pulley, which I removed needing to get to the alternator bracket. You'll also see that I'm putting the fan back in without a shroud, and that's because I'm going to put a radiator kit in at a later date, and I didn't want to do too much in one video, otherwise I'm going to end up running out of content. Now you might ask me, why do you want to put a 240 amp alternator in? That's a good question. I don't really know. I did, however, have a 110 amp hour alternator in my 100 series FTE, and that thing ran 2 Ultravision spotlights drawing, it was either 15 or 30 amps each. It was a lot, maybe it was 15 amps each. I also had a 40 amp DC charger on board, and then if I had the little caravan on the back, that also had a 40 amp DC charger. So if you're pairing all that up, that's 40, 40, there's 80 amps plus another 30, says 110 amps just in those 3 items. And I tell you what, the car didn't like it. The volt gauge was down, the lights were dim. So you could bump it up to a 170, which would sort of normally be the go-to, the 150 to 170 amp range. What I'm doing here is checking the continuity between the alternator cable at the back of the alternator and where it goes to the fuse block at the other side. I don't want to cut it off just in case I want to put it back to standard and reuse it, so I'm just going to tape up each end to make sure that they don't rub against anything. Not that there's any power going to it. At the same time, I'm also going to change both fusible links because they're both pretty unhappy, and the fuse block itself was actually heavily corroded, so that's going to be changed. Clean up the wiring and all the battery terminals, and in place I'm going to replace the positive terminal with a mega fuse positive terminal. So that includes 1 mega fuse, which will hold a mega fuse of your choice, which in this instance will be about 250 to 300 amps, and then there's also 2 MIDI fuses on the side which you can use for accessories, and then the fusible links can actually run in front of those fuses because they obviously are their own fuse. Now I'm just trying to work out where to run the cable in the best spot. Have to modify this positive terminal a little bit, no big deal. Bit of a hacksaw and a file away. Get her back on, fit her into position. Now you can just use a mega fuse or something like that and mount it to the inside of your firewall or whatever, but I chose to run a terminal to be a lot cleaner. Here's the cable all conduited up and terminated at both ends with the correct length that I wanted. It's still a work in progress, but it'll do the job. The beauty about running this positive fuse block is that you can still retain the fusible links, which is what I wanted to do. I wanted to keep it as factory as possible, but there wasn't really a fuse link I could use that was that big, so mega. Done. Did the old negative terminal test, make sure it wasn't going to spark. Next on the list is a Victron Smart Shunt. Now this thing is great. I'm in love with it. It's so good. You can pair it up with a Bluetooth on your phone. It connects to an app. It shows you your current draw, your input amps, your output amps, your real life battery time before it goes flat. You just put in your amp hours of your battery. When you start the car, it shows you how much current draw it is on startup. It's an amazing piece of work. And it just hooks up to the negative terminal, so pretty much all your negative goes to the smart shunt, and then from your smart shunt to the battery, and that's it. And then there's a little wire which runs to the positive side of the battery, which you fit up, and then you can run another one to go to a second battery so you can actually read off both. But at the moment we only have 1 battery, so we're just going to do the one, and then we'll do a quick visual on how it works. Shortening the smart shunt sensor cable for the positive side of the battery here, because it comes about 3 meters long, and I'm really trying to reduce messy wiring in this engine bay, so it's shortened. It also has its own little inline fuse, which I didn't want to use, but I feel like I needed to, so I did it right up near the positive terminal so I can't get lost in the abyss like all the other fuses were, because that was the biggest problem with this thing. There was fuses everywhere, inside the guards, underneath things, screwed to things. Alright, here we go, first start up. Beautiful. Now I'm freaking out, like, is this alternator going to be too hot? Is it, you know, going to be cooking? So I'm checking the voltage, and then I grab the old thermal imager out. We do a run around of the car, make sure that the cables aren't stinking hot, make sure the alternator's not cooking itself, make sure there's no high resistance spots with loose terminals or whatnot, and I was very impressed. The positive terminal still needs to be secured much better than what it is, but the car's running and that's the main thing. It's doing its job. And how good's the thermal imager? I love this thing also. I'm just a bit of a tech nerd when it comes to this sort of stuff. Now, don't panic, that red, orange, yeah, it looks like it's very hot, but if you have a look at the top left corner, it's only 19 degrees. It just shows the hottest part of the screen. And then on the right hand side it shows you the maximum temperature it's reached at the time and the lowest. But this thing's really good for diagnosis on you know, cylinder misfires or blocked radiators and things like that. So it's very good, and I'm glad that I have it to use. They're also good for checking things like blocked exhausts or block cat converters, because one side of the cat converter will be quite hot and then the other side will be quite cool, and that will determine if you've got a blockage, which is fantastic. But battery's stone cold, which is good. That's the main thing. Now I know it's not finished, but here's just a quick walk around. We've got the positive cable, run it up round over the top of the radiator, which I'm going to put a P-clip in place. Smart shunt secured to the battery tray and the side of the inner guard. Everything's sort of nice and neat and out of the way. I've re-secured the spill control valve, little module thing, which is the bane of everyone's existence when they have a poor connection and want to stall and carry on. There she is. What a darling. Smart shunts. They're quite cheap. I picked that one up off eBay. It was about $100. First test. 300 amp on startup. Now this is at idle, so we've got 20 amps going in, drops it down to 14. We'll turn the headlights on with the high beams and the blower motor, flat knacker, and I think still it only just puts in what it needs. 8 amps, 13.8 volts. I was a little bit concerned at first with the low current going in, but then I realised you never see how much current goes in with your alternator. You only check the charge rate, and after doing a bit of investigation, it only just puts in what it needs. So as long as it's charging and the amps is going in, it's fine. But we did do a dead short check, which we'll show you shortly. Happy with that. Airbox can go back in, and we'll put it back together. Try and get a road test out of it. Alright, here we're doing a fast idle dead short check with a manual battery meter, and see how it jumps the amps right up to 50, 60 amps, just what it needs. If it doesn't need it, I won't put it in. In the next shot we'll do the same thing at idle. This is at idle, which I was also quite impressed with because it still bumps it up to about 50 amps at idle. And just a quick screen grab of setting up the app, logging in, showing the details that it runs. Thanks for watching, guys. We'll do some more information soon, more videos. I hope you enjoy it. Give me feedback. Look, I'm sorry it's a bit of voiceover, a bit of real time. It just work gets involved and it just becomes too loud. So catch you later.